I'm trying to share my screen. You should be able to see that in a second.
Okay, so the joys of online meeting, and we always think that tech never breaks down, but we all have challenges with it, but I think we're doing well today. Yep, I can see the screen. I think everyone else can. Don't forget, guys, question and answers into the panel. Anything you want to ask Marcin as we move forward, or any other questions as well, then please drop them in there. So Marcin, over to you.
Thank you very much, Dean. So let's start. Before we begin with the presentation, let me talk briefly about myself. So my name is Marcin Natanek. I have been a software engineer in infrastructure and process automation for over 6 years. And currently, I'm a cloud consultant for Cogniflare. And I use Kubernetes every day in Google Cloud to host critical production systems. That's basically my day job. And about you. So this presentation is adapted to be beginner friendly. However, I will not explain basic concepts like APIs, YAML, Docker, or Linux. Most of those things should be quite familiar to you. If you cannot keep up with the technical terms that we use here, you can always revisit this presentation in the recording because the recording is rolling live. So about the presentation. So we will talk about what Kubernetes is. We will talk about where did the Kubernetes architecture come from, what was the inspiration behind it, how it influences the business processes when you use Kubernetes in your organization, how is this useful to you exactly as a developer, and I will do a quick demo of a GKE cluster on GCP, so stay tuned for that. So let's start with what Kubernetes is. If you visit the homepage, it says that it is a production grade, so basically very stable, container orchestration solution. So container orchestration means that you basically have a either Docker or maybe some other kind of container, basically a containerized workload, and you can quite easily run that on top of basically anything, because it is Kubernetes allows you to orchestrate the containers, so basically manage the containers for you automatically on top of any kind of hardware. So because this is a Google Cloud Platform meetup, I would like to mostly focus here on the Google's implementation of Kubernetes service, which is called Google Kubernetes Engine, or in short, GKE. I will just say GKE to save time going forward. So it allows you to quickly and cheaply set up a working cluster and start learning basically with a very generous free tier. So it's basically quite easy to start in Google Cloud. And to better understand this whole Kubernetes platform, let's talk about its origins. So where did Kubernetes originate from? So originally, it was, of course, developed in Google, and it is based on their own internal container or maybe not even container, but workload management solution called Google Borg. It is very monolithic and tightly coupled. I personally never worked in Google, but I heard quite a few opinions that Google Borg originally was very tightly integrated with a lot of Google tools, and you couldn't use that separately in non-Google infrastructure because it was so infused by the Google's mindset to managing the even physical infrastructure. So they were not able to quite easily open source the Borg project, but it gave the inspiration to a more elastic project, and the one that's designed to have many easily swappable parts that fit non-Google needs. And that project is Kubernetes. So let's leave Google for a second. And for the sake of simplicity for this presentation, let's imagine a made-up company, and we'll basically show a manual procedure that they are using to manage their own workloads inside their own physically managed data center on top of their own physical machines, physical servers, without using any Borg or Kubernetes automation. So let's assume two tech silos that are working for this company. There are developers that are creating the software, and operations. Those are the operators who are basically taking the compiled version of the software created by the development and installing that on top of some hardware in order to run it. Both of those silos usually contain multiple teams, but we'll just focus on a single one. So keep in mind that usually with those kinds of organizations, we are talking about thousands of people working together. So let's have a look at a single development team. They're just brand new, freshly created, freshly recruited people to the company. They all code in Java. They had their own original requirements for the application they're creating, and they basically provided their compiled application as a jar file that can be installed on top of basically any infrastructure. So it's time to do the first deployment of their own application, and let's see how this process looks like in this whole company that they're working in. So this is the developer from the dev team that we mentioned. And he basically needs to send an email with the specification of the application. And let's basically have a quick look at the contents of such email, what it can contain. So there's the description of what the application is doing, the build artifact as an email attachment. This is the jar file that I mentioned. The dependencies, so other libraries that are required, so other jar files, maybe some bigger requirements, or assumption that it needs to run on Linux or something like this. And memory and CPU requirements, so expected amount of memory and CPU that will be consumed by just running this single instance of this application. So all of this is required by the operations to properly assign a space in their data center to run this application and to manage it in the future. So that's for the continuity. From the other side, these emails have to be reviewed by somebody. And here let's introduce a first person from the operations side. This is Joey, and his task is basically to read through those emails, comb through them, and verify whether all the requirements are valid and reasonable. And if not, he needs to highlight the issues and ask for more information. So he comes back and forth with this email chain basically every day. There are hundreds of emails coming to his inbox, and he needs to verify all the information and specify all the errors and maybe make corrections by just coming back to the developers. He also is responsible for verifying the requirements against other policies, like security policies that are used in the organization, and the resource allocation policies, like they cannot out of sudden require you to run something on a 3,000 gigabytes or 3 terabytes RAM cluster, because this is not something that we can provide out of the box in our data center. And when he actually gets a requirement that is correct and already approved, then he needs to deliver that requirement to a central database that can be later referenced to discover which services are already assigned where in our server room. So then he saves that in an Excel spreadsheet that's hosted on SharePoint. That's just the technical choice that they made to manage this whole operations division. And notice that the developer, that's actually a nice thing about this process, that the developer doesn't need to understand exactly where this data is stored. He never sees this Excel. His full interface is just sending the email, and that's it, and clarifying issues. So there are other members of the operations that check the database for new requirements and introduce those changes that are basically appended to this Excel spreadsheet to the system based on those requirements. So one of those people is Chandler. He manages the company servers and services running on top of those servers. And today he needs to install our Java application on one of his machines that he is basically responsible for. And to do this, he needs to assign one machine that has enough resources to run our Java application. So basically that's the server that he assigned here. He has also another very important, very crucial responsibility. When the server breaks, he needs to basically find a replacement server for that. So that's what he did in this slide. So let's scale this process. Let's see what happens when you have more and more developers developing more and more applications, and maybe you're having more and more outages because the servers start basically reaching the end of life, and they lose their guarantee. So we can see that at first there's not much going on. There are just more developers going onto the mailbox, and the communication is going as previously. But when you scale that further, you can very clearly see that Joey and Chandler, those people working in operations, they are not able to keep up with the amount of work they need to do. You can, of course, hire more people who will be doing this work and scale that horizontally, but there are breaking points still, because what happens if SharePoint goes down in this example, or if you cannot send an email? Very critical outages can happen basically out of just using those flaky tools to manage the infrastructure. So let's try to introduce some automation to this process. But before we introduce an automation, we need to standardize the interfaces inside this whole process, business process. So basically, it means that we need to make the communication in this process more strict and formal, leaving no room for errors, and making the good anchor points where the automation can actually be attached. So let's see how we can use actual Kubernetes components to do this in this exact process. So we'll start introducing Kubernetes concepts from now on. So let's have a look. First, let's introduce the Kubernetes API. Usually its official name is Kube API Server. So it can be used as a single point of contact for all developers, and not only developers, but also other automation, because it provides a standard shape of requirements for our workloads. And it's basically similar to the email structure that I showed you before, but it has a very formal structure to it. So you cannot have 3 or 4 or 10 different ways on how to specify information about the amount of CPU required by your workload, but you always have to use a single specified way that has a official schema, and that is the standardization that I mentioned previously. And also it automates so it gives you better, more manageable solution than Outlook to be hosted somewhere and managed separately, so that your infrastructure doesn't go down with an outage or an upgrade for your Outlook inbox. And yeah, let's move on. Another part that I would like to mention is an admission controller. So it's basically doing exactly what I just told you about Joey. That is the task of verifying the information before putting that into a centralized database. So whenever any developer comes with their new specification for an application that should be running in our cluster, the admission controllers, of which can be many, and you can also create custom ones, their job is basically to validate whether your specifications are correct, valid, and they adhere to the company policies or the cluster policies in this example. If everything is correct, then that can be saved into the central database. But before we move on, let's actually highlight that Joey's job in this example was completely automated. So what can we do about this specific example? What can we do with Joey? Is he obsolete now? Can we fire him? Should we fire him? So my answer to that is no. Joey has a very special purpose now in the development team. Basically, he now can be included in the software development process and use his knowledge of the target environment, of the cluster that he was working on previously, and he can basically make the whole software development lifecycle much smoother, because when he cooperates very closely with the development team, you can catch many possible production issues very quickly. He can also share his knowledge about the logging practices and so on. All of that can be included now in the development process. Additionally, Joey can learn to program from all the other developers and start automating boring procedures that he has been carrying out previously manually. So now those people working together have much better value than being separated into separate silos. And because this dev team has a member of operations now, we can rename that to the DevOps team. And that's what usually you can see being referenced as when you hear about the DevOps culture. DevOps culture is basically the culture of creating the basically creating the teams that contain multiple different specializations inside a single team. So let's take a closer look at the standard requirements format. So here, instead of the jar files and the emails, the developers are basically creating a Docker image and reference that inside a Kubernetes object. So Kubernetes object is just a YAML file that specifies exactly in a very formal manner what we want to run on our cluster. And let's have a look at example YAML file for an application. Here we just specify a simple pod, where pod is just a set of containers with a shared disk space. And those pods can additionally expose some ports. So here we are just running a custom Java application that we provided as a Docker image. Its name is my Java app exactly. And it is exposing a port number 80, so HTTP port over TCP protocol. So thanks to this specification, it's just a few YAMLs, lines of YAML, and those are enough to actually run a fully working service in Kubernetes. And there is very nice property of those YAML files, of those Kubernetes objects, or those manifest files, because that's how you usually call them. And this declarativeness means that we're not specifying how to run our application, how to install it, and how to manage the possible errors, but we're specifying what we want. So what is expected of this service, what kind of assurance we want, what kind of availability we want, what kind of usage we can expect from the service. So we don't have to specify step by step how our cluster will manage getting this service running. We're just specifying what we want. So another part that I wanted to mention from the Kubernetes architecture is the etcd. So that is the central component, and that's the central database that stores all the Kubernetes objects that were provided and approved by the admission controllers in the past. It means that this is a very reliable, secure database that hosts all the information, all the current information about your whole cluster. So whatever is known by Kubernetes about the whole system will be stored inside this etcd. And now we can replace Chandler as well. Of course, we should not be firing him. We should be moving him into another team. And there are two components that are doing the work that we just mentioned. First of all, first of those is scheduler. This part is basically tasked with finding a new assignment for each new job. So if we create a Kubernetes object that specifies that we want to run a pod, scheduler will need to take this pod and assign a node that this pod will be running on. In case of a failure, the scheduler as well will have to reschedule this specific pod to another machine. Additionally, there is the node controller part, which basically manages monitoring, pinging, and everything else about the nodes themselves. So it monitors the processes running on all the nodes and so on. And last part, we have kubelets and kubeproxy. Those are small processes attached to the nodes that basically communicate with the node controller and the etcd database, and those report all the status of the nodes directly to the whole cluster. So here is the whole Kubernetes architecture without all the business part. You can see that there are two different categories that we can use for talking about all those elements. There is the control plane, or the master plane, or the Kubernetes master. Whenever you hear about those, you can think about the scheduler, the API, the etcd, and the controllers. There are more controllers, but we only covered the node and ambition controller. All of those are used together to host the master. And then we have everything that's running on the node. Of course, those are the tools that we mentioned, plus the Docker. And here is another slide. Basically, that's stolen directly from the wiki page. It's the official documentation on how this process looks like. So now you should be able to fully understand the architecture of Kubernetes and how it basically affects your process in the business. So there's one part that I wanted to mention, because on this image, you can clearly see that this green part is the Kubernetes master. It needs to be highly available because it hosts the server and all the centralized information. So if this goes down, you completely lose the ability to manage the entirety of your cluster. So you might have outages because of that. And this is what the multi-master mode actually achieves. You can run multiple master instances that coordinate together to provide highly available service. So even if one node goes down that the master is running on, you can always use another one. And this is something that is actually solved for you automatically when you use GKE inside Google Cloud. They automatically create the masters in a specialized project that you don't have to manage, and you can actually never manage this one. So this is something internal to Google Cloud, and this is proved to have extremely high availability because of how critical this part is. So now we have answer to where did the Kubernetes architecture come from. So let's reiterate. It was created in Google based on Borg. It was created by standardizing and automating work in the technological division of a big business, and it was designed to be highly customizable and to fit many use cases. So how is this useful to you? So first of all, it allows you to easily introduce DevOps culture to your organization. And this is all about healthy cooperation between the tech workers of different skill sets. And that is something that is very difficult to get wrong if you use the right tools. And in my experience, adapting Kubernetes to the organization actually breaks the boundary of the development and operations and forces these people to actually work together to achieve their common goal. And this is very beautiful about this one. Another part is the standardization. So it is easy to recruit, easy to transfer engineers between the projects because all of them are using a shared set of standards for communicating what they want and how they want to run it. Additionally, the standardization is very important from the standpoint of the backend of Kubernetes, because there is a concept called cloud controller that I did not want to talk about too much. But by just swapping this simple controller, you can easily move Kubernetes clusters between different data centers or even clouds. So, for example, if you want to move your service from Google to AWS, for example, it's easily achievable by just swapping the implementation of Kubernetes that you're running, and your Kubernetes objects that you have specified for your application, those should be easily transferable between the different Kubernetes clusters. So that's the upside of standardization. And with that comes the portability. So you can easily install your service on top of other Kubernetes clusters. So if you develop something against Kubernetes once, you can run it anywhere. And the adaptability, so it comes from the other side. If somebody has a third-party service running in their cluster, quite easily, you should be able to get it running in your cluster as well. So that concludes this part. Now I have a demo prepared. Tim, how are we on time?